topic for today's discussion is the second most prominent type of prompt engineering techniques, that is multi-shot prompting, which incorporates both one-shot prompting and few-shot prompting. In this video, we'll be introducing first the meaning of multi-shot prompting. Second, using an example, I'll tell you the difference between one-shot prompting and few-shot prompting. Then we'll be checking out a use case that is solved, a generative AI use case that has been solved using multi-shot prompting. Post that we'll be discussing a few limitations with respect to multi-shot prompting, and lastly the use case that we saw theoretically, we'll try to implement that particular use case of how to solve a generative AI problem using multi-shot prompting. We'll be implementing that practically. We'll check how to implement multi-shot prompting practically in a Python notebook. In the last video, we discussed the main characteristics of zero-shot prompting, that is, we use the base knowledge or the knowledge that the model has based on the pre-trained data directly to solve a business problem, and we do not expose the model to any type of examples for it to refer from. But if the problem statement is very complex in nature, or it is a problem statement which the model was not exposed to while it was pre-training, that is, the training data didn't have such type of problem statement, right, the model will not be able to give the correct answer. In these scenarios, we give in context examples. In context means we give a few examples inside the prompt, or we prefix the prompt with a few examples for the model to refer from or to learn from, so that the output is enhanced and it matches our expectations. Giving an example of multi-shot prompting, let's say the task at hand is to correctly use a new word in a sentence. The new word is fardoodle. This word is not from English vocabulary, so the model or the LLM is not exposed to this word initially. If I directly ask the model to implement or to use this word, that is fardoodle, into a sentence, it will not give me a correct answer. Instead, what I do is I give a example, a similar example to what I am expecting the output to be. That is, another word which is not from English vocabulary. A watpu is a small furry animal native to Tanzania. An example of the sentence that uses this particular word, that is watpu, is we are traveling in Africa and we saw these very cute watpus. Since I have given an example for the model to refer from or to learn from, if I give this particular question now, it will give me a response which matches my expectation, or which I was expecting from the large language model. That is, we won a game, we started to fardoodle in the celebration. If I would not have given this example to the model, the output would not be correct, or it would not match my expectations, because the word fardoodle is a new word which the model has not been exposed while pre-training. Hence, it would not know what to do with it. It won't be able to make a correct sentence with it. Hence, I have given it an example to learn from or refer from. Coming to the difference between one-shot prompting and few-shot prompting. Both of these, one-shot and few-shot, are the subtypes of multi-shot prompting. The only difference is, in one-shot prompting, we just give a single example for the model to refer to. As in, on the left side, I have only given one example for the model to refer to, and in few-shot we give more than one example. That is, on the right side I have given 3 examples for the model to refer to. Let's try to understand the difference between two using an example. The example is a use case wherein we are asked to predict the product review sentiment. Let's say there is a new product that has been launched into the market recently, and there are multiple customer reviews on the e-commerce website, and we are tasked to check out the sentiment of each of those customer reviews. One of the customer reviews in this particular use case is the product was fine. We need to classify this particular the sentiment of this particular review, customer review, amongst these 3 categories, that is negative, neutral and positive. Now, since I have 3 different categories, and in one-shot prompting I am allowed to give only one example, there is a high chance the model will not get exposed to the properties of all these 3 categories, because I am giving just a single example. That example can either be positive review, negative review, or a neutral review, but it won't be exposed to all the characteristics of all the three categories. Hence, if I give the product, the customer review of the product, that is the product was fine, which according to me is a neutral review, the model predict this as a positive review, a positive sentiment, which is wrong. Coming to few shot prompt engineering, where we give multiple examples for the model to refer to. Since we have three different classes, we give three different examples, one example each, that is a positive review, an example of a positive review, an example of a negative review, and a positive and a neutral review. We give three different examples of each category or each class. Now, since the model knows the characteristics of each of these three classes, since it has been exposed to three different examples, it will give us the right answer. This is the difference between one shot and few shot prompting. Now let's try to comprehend the essence of multi-shot prompting using a Q&A use case. The objective in this use case is to answer this particular query leveraging a large language model or a generative AI model. The query says that a customer invested $10 and got $20 after 2 years. What is the return of investment? That is, what is the return of investment of a customer who had invested $10 2 years back and got $20 today? It's a simple mathematical question that needs to be answered using an LLM. Let's say we are using Falcon LLM, open source LLM, which we'll be seeing practically when we are implementing it in Python notebook going forward in the video. Let's say we are using Falcon LLM to get the answer of this particular query. The first methodology that we apply is use zero shot prompting, where we do not expose the model to any examples to refer from. The response that we get is 10/2, which doesn't make sense and is a wrong answer. The second methodology that we use to get the answer is few shot prompting, where I give two examples for the model to refer from or learn from. And these two examples are in the same line or similar to the query that I need the model to answer at the end. For instance, the first example is the customer invested $10 and got $15 after 3 years. What is the ROI? And I give the answer for that respective question, which is similar to the query that I want the model to answer. Given these two examples, I get a right response saying that there is a 100% return of investment to the customer. This is the main essence of multi-shot prompting, which exceeds the zero shot prompting, giving the model reference with respect to a few examples. The examples should be in the similar line to the query or the task that needs to be solved at the end, and the model learns from that and tries to give us the enhanced output or the right answer. Coming to the limitations of multi-shot prompting. The first major limitation of multi-shot prompting is its scalability and its practicality. Providing examples for highly specialized tasks with every possible variation and every possible scenario becomes very impractical and a time-taking process. Let's take a use case of a legal system wherein we have very complex legal language and there are a lot of technical jargons involved, right? So creating every possible scenario, every possible relevant example, every permutation and combination becomes very time consuming, and the person who is doing that should have a lot of domain expertise. Hence, while we are dealing with such domain specific tasks or tasks with that have very complex technical jargons involved, using few shot prompting becomes a bit impractical. Coming to the second limitation, that is overfitting to examples. Since we give examples for the model to refer to with respect to multi-shot prompt engineering, there is a chance that the model might overfit to these examples. That is, in the unseen data, that is the queries that we are trying to ask post we have exposed the model to these examples. If there are similar queries to the examples that are provided, the model gives a valid or a good or an expected output. But if we give slightly different queries with respect to the examples that it was exposed to, it might perform poorly. This is the problem of overfitting with respect to multi-shot prompt engineering. The third limitation of multi short prompting is the context length limitation. So as we had discussed, all the examples that we give to the model are in context, right? So every model, every large language model has a maximum context length that they can handle. For instance, GPT 3.5 Turbo cannot handle more than 16,000 tokens in its context. On the other hand, if we talk about smaller LLMs, that is for Falcon 40B cannot handle more than 2048 tokens in its context length. So providing too many examples, that is examples which exceed the limit, the context length limit, might truncate the input and we might lose on critical information. So the model won't be able to refer to the examples which have been truncated because the number of examples had crossed the context length. This is the meaning of context length limitation. Now coming to the last part where we'll try to or learn to implement the theoretical use case which we just saw in the video. We'll try to implement it practically using a Python notebook. For that, we first install text generation library which helps to generate text using a large language model. In this particular notebook or to solve this particular task, we are using FLAN T5XXL model or large language model, which is an open source model hosted on Hugging Face infrastructure. Next, we import client and inference API client from the text generation library. The client class is used for general interaction with the API. Since the model is hosted on Hugging Face platform or infrastructure and we want to reference it over here, we need a API interface for a communication or a medium of communication. The inference API client provides methods for performing different tasks such as different inference tasks such as generating text, translating language and answering questions. Hence we import these two from text generation library. The next thing that we do is we define a LLM request function. The primary objective of a LLM request function is to communicate or leverage the model that is hosted on the Hugging Face environment or the Hugging Face infrastructure. We pass two different parameters, that is first is the type of model. Over here we are leveraging FLAN T5XXL. It can vary based on your personal preferences. The second thing is the token or the authentication token which is required for any API communication. Right, this particular access token or the authentication token, you can find it on Hugging Face website for free. We get a response using these two parameters with respect to the prompt that we have. This particular prompt is passed as a input parameter to this particular function which comes from prompt creation function. So as discussed in the last video of zero shot prompting, we created a dynamic prompt containing three different components, that is the prefix, query and the context, which are the three components, basic components of any prompt. Over here, since we do not require context, we are only using the prefix or the instruction and the user input query to form a dynamic prompt which is being passed to this particular function of LLM request, which in turn gives us the respective output or the desired output via an API call to the model that is hosted on the infrastructure of Hugging Face. Now coming to the example that we saw, theoretically, the query was the customer invested $10 and got $20 after 2 years. What is the return on investment? This was the query that we saw. In zero shot prompting, we do not expose the model to any examples, so we do not pass any prefix, no examples, an empty prefix, and we pass the prefix, that is empty string, the query, that is the objective, and the model function that has to be used for getting the response, that is call HF FLAN T5XXL. We get a response of 10/2 which is inappropriate. Coming to the second part, wherein we leverage few shot prompting, that is we pass two examples which we saw in the theoretical example. If we pass this as the prefix, that is the prompt over here gets two examples as the part of prefix, and then the query, that is a customer invested $10 and got $20 after 2 years, what is the ROI? We give this particular query post the prefix, that is these two similar examples, and then pass this particular prompt, dynamic prompt, to this particular function for LLM reference. That is via an API call we want to get the answer of this particular query of the or this particular prompt. We get a right answer saying that there is a return of investment of 100% with respect to this particular query. This is the difference, practical implementation of multi-shot prompting in a Python notebook, and the difference between zero shot and multi-shot prompting.
Please do not forget to like the video and subscribe to the channel for more such informative videos related to artificial intelligence. Thank you.